Yes, factor. We've got lots and lots of things to factor on this one.
I swear I hate these boxes so much.
Well, then do a different method.
I don't know that any other method.
Well, then do the factoring. You got to do it, okay? So, on x plus 2, that's already a plain old x, not an x squared, right? So, that one's done. Now, let's look at x squared minus x minus 20. So, what numbers add to the negative 1 but multiply to negative 20? Okay, while you figure that out, I'll set up my pieces here.
4 or 5.
Which one should be negative?
Negative 5 and 4.
Good. Why isn't it letting me? Ah, there we go. So then I take my GCFs out, right? And then, so right now I have x plus 2, and then x plus 4 and x minus 5 times 3, right? I already took the GCF for you out of that top one, but now we got to factor that one. So I need two numbers that add to negative 7 and multiply to 10.
Wait.
Which should be negative.
35. Wait. Yeah, the 5.
Both of them. How do I multiply to a positive number but add to a negative number? Daniel, Keegan, you guys paying attention?
Yeah, sorry.
Yes, but sorry. That means one of those was a lie. Sequoia.
So like on the one that you did before, why do you need to use the box when you can just look at it and say x plus?
Very good. The reason I'm showing the box is because I only showed the puzzle on last time's stuff, because then you can just write them. But if my A isn't 1, you can't just write them. And I was noticing as people were coming in to get help that everybody forgot how to factor when A isn't 1. So now I'm just going to show the box every time. Does that make sense? But you're right. If A is just 1, I can just write the numbers. But because I just did that shortcut again, just so everybody hears that, last time, and we didn't do any in class where A wasn't 1. Everybody, like every single person who came in for help got the factoring when A isn't 1 wrong. So I want to make sure we do at least 1 or 2 of those today. And I'm going to show the box every time. Does that make sense, Sequoia? Yep. And hopefully to everybody, that's why I repeated it. Okay?
Got it.
Okay, now what about 3x squared minus 12? What do I do first?
GCF.
Very good. Take the 3 out. So when I take that 3 out, I'm left with x squared minus 4. Okay, you can do the box still, like add to 0, multiply to negative 4. Or this one is our binomial factoring trick, right? Where you can take the square root of each piece and do one positive and one negative. Daniel, I'm about to make you sit in the front row center, right? Like little kids watching a baptism. You know what I mean? That's what I'm literally about. Okay? If you turn around one more time, I'm going to give you a clipboard in your front row center. Yeah, right? Yeah. Yeah. That's called classroom management. I say funny things and see who laughs, then I know who's listening.
Well, I was obviously listening.
Oh, good job.
Yeah.
Okay, so whether you do the trick or the box, did I give you guys enough time to factor that? Right? Okay, so then this is my x minus 2 times x plus 2. So stop here and ask me questions before I start canceling a bunch of stuff out, reducing away.
Oh, reducing's the easiest part.
So normally when we've canceled out, they've been on opposite fractions. Would it still work with the x and plus 2? The x minus 2?
Well, they're not opposite fractions, right? The idea is we are multiplying straight across. So I just wrote it as a single fraction this time, right?
So it would work.
Uh-huh.
Cool.
Okay, so what can go away?
X minus 2, x plus 2.
Okay, anything else?
Yeah, the x minus
X minus 5.
Yeah.
X minus 5.
Yeah.
Anything else? The 3. Now hold on. Is the 3 gonna give me a root / excluded value?
No.
No.
Why not? Can I have somebody who I haven't heard from yet today raise their hand and tell me why the 3 does not give me an excluded value?
Sure.
Can I have somebody? Yeah, please.
Because it's not connected to an X.
Perfect, because it's not connected to an X. So it's just a number. So there's no way to change it because it's not connected to an X. Now, remember, we have to look at any denominator in the problem. So how many excluded values, so numbers connected to X from denominators, are there going to be? First, just tell me how many there are. 4. Very good. So X cannot be -4, 5, 2, and -2. And my final answer is 1 over X plus 4.
That makes sense.
Da, da, da. Okay, let's do another one with division. Okay, any questions on that one?
Nope.
Okay, let's try another.